Welcome to the law of conservation of heat with Ma'am T. Let's take it back a bit. In primary school, you learned about the principle of conservation of energy, which simply stated what? Energy cannot be created nor destroyed, but it can be transferred from one object to another, or it can be transformed from one form of energy to another. So the law of conservation of heat basically looks at two objects that are brought into contact with each other. These two objects are obviously at different temperatures. So we want to understand what is going to happen when these two objects are brought into contact with each other. If I have object A at a higher temperature, and I bring it into contact with object B, which is at a lower temperature, there is going to be movement of heat between the two objects. And what do we know? Heat is energy in transfer from one object of what? Of a higher temperature to an object of a lower temperature. So it means that the one with a higher temperature is going to transfer heat to the one that has a lower temperature, such that we reach what is called a thermal equilibrium, whereby both the objects will be at the same temperature. Then we know that thermal equilibrium has been reached. So object A is no longer going to be transferring energy to object B, and object B will no longer be absorbing heat from object A. Once thermal equilibrium is reached, object A is no longer going to transfer heat to object B, and object B is no longer going to be absorbing heat from object A. So the law of conservation of heat simply states that the amount of heat lost is equal to the amount of heat gained when there is no heat lost. This part always confuses the learners, because you cannot tell me that heat is lost is equal to the amount of heat that is gained when no heat is lost. Let me explain what I say. I know that this object is going to lose heat, and this object is going to gain the heat that is being lost by this object. So this part, when we're saying there is no heat lost, we are saying the energy or the heat that comes from this object, all of it as it loses it, all of it is going to go to B. This is not going to lose the heat to the surrounding. This is what we mean when we say no heat is lost. So whatever heat A is going to release, it will all be absorbed by B. So what is the mathematical expression for the law of conservation of heat? Q absorbed or gained is equals to negative Q lost. Remember, an exothermic reaction, we see it by a negative, showing that heat is being lost by the system. And if it's an endothermic reaction, there is a positive, even though we did not write it here, that shows that heat is being absorbed by the system. Another thing that we know that Q is a symbol for heat. And from the previous video, we learned that heat can be calculated with the formula MC delta T, which is equal to negative MC delta T. Delta T, I know it is what? It is the final temperature minus the initial temperature, which is equal to negative MC final temperature minus initial temperature. This is something that you need to know. In the formula sheet, you'll be given Q is equal to MC delta T. You now need to apply it to this law. I hope you understand what I'm saying. So now, we know that one object is going to come with a higher temperature, and the other one is going to come with a lower temperature. Then we need to be able to identify which one absorbs and which one is going to lose the heat. How are we going to identify that? It all boils back to the temperature difference. This one, because it has a higher temperature, it will then do what? It will then donate heat. So the moment it donates heat, it means this is going to be lost and this one is going to be gained. Another way you can identify this is look at the temperature changes. The one that is going to absorb the heat, it is going to have a lower initial temperature but a higher final temperature. The one that is going to lose is going to have a higher initial temperature and a lower final temperature. So this is how you need to be able to identify which one absorbs and which one loses. Because if you get it wrong, your whole problem or your whole solution is going to be incorrect. Let's do an example to prove the law, that the law is true. Let's say I have two beakers. This beaker has 100 milliliters of water. I added to another beaker with the same volume of water, 100 milliliters. Together, once they are added together, I get another beaker, the mixture of the two, and the volume is what? It's 200 milliliters. So if this beaker has an initial temperature of 40 degrees Celsius, this one has an initial temperature of 60 degrees. And I tell you the final temperature of the mixture is 50 degrees Celsius. I want you to prove for me, I want you to prove to me that the amount of heat that is gained by the substance or the amount of heat that is being absorbed by the substance is equals to the negative of the heat that is being lost by the substance. So what are we going to do? We first need to identify which one is going to absorb the heat and which one is going to lose the heat. How are we going to do that? We are going to look at the temperatures. This one moved from a 40 degrees, and this one, the initial temperature is 40 degrees and the final temperature is 50. So what happened to the temperature of this one? The initial temperature was low, but the final temperature is high. So this one is going to do what? It is going to absorb. When we look at this one, the temperature is 60 initially and the final temperature is 50. So what happened to the temperature? I started with a high initial temperature and I went to a lower final temperature. That means the heat is lost. So let's calculate and see if these two things are equal to each other. Oh, another thing. We are not given the mass in kilograms. We are given the volume of the water in milliliters. So how then do we convert it to kilograms? So whenever you're given a milliliter and you want to go to a kilogram, you are always going to divide by 1,000. Please keep that in mind. Because what do we know? We know that 1 liter is equals to 1 kilogram. Okay? And we know what? 500 milliliters is half of a kilogram, which is 0.5 kilogram. This is basic thing that we know. We also can take it to grams. 1 liter is equals to 1,000 grams. So it means what? 500 milliliters is equals to what? It's equals to 500 grams. These are basic things that you learned in grade 10. You need to know them. So let's look at this. So I'm going to have Q is equals to MC final minus initial. So I'm going to have 100 divided by 1,000. Because it's water, we know the specific for water to be 4184. I won't advise you to actually cram it because some examiners like to round it off to 4,200. So pay attention to the one that's given on the question paper so that you don't forfeit marks. So 60 minus 40. And then the final answer will be 4184 joules. Be careful with your units. No unit, no mark. So this is for Q absorbed. Q lost. We didn't write for absorbed, but let's correct it for the side. MC delta T. Okay. So it's going to be what? 100 still divided by 1,000 multiplied by 4184. Final is 50 minus the initial, which is 60. Final answer, negative 4184 joules. Is the law proved? Yes, we proved the law because the law is telling us what? The law is telling us that Q absorbed is equal to the negative of the heat that is lost. Look at the values. Q absorbed is 4,184. Q lost is equals to negative 4,184. The negative of the Q absorbed. So this law holds. Let's do practical examples. Example 1. Calculate the specific heat capacity of copper if 80 grams of copper at 185 degrees Celsius is added to 100 grams of water at 10 degrees Celsius in a polystyrene cup and the highest temperature reached is 22 degrees Celsius. So before I do these calculations, I like drawing schematics for myself to make sense of what the question is saying and what they are asking me. So let's collect the information. They want me to calculate what? The specific heat capacity. So they want me to calculate the small c. For what? For copper. This question is just, I don't know what word to use, but we know from the table of specific heat capacity, I'm able to find the specific heat capacity for copper there, but they actually want us to prove that it is actually that value. So let's just do it. And they're telling us that the copper is what? The mass of the copper is 80 grams. So mass of the copper is 80 grams. I need to convert it to kilograms. Right? So I'm going to do what? I'm going to divide 80 by 1,000. Then they're telling me that it is at a temperature of this. That is my initial temperature. Then they are adding it to what? To 100 grams of water. So again, mass of the water, 100 divided by 1,000. The water is at an initial temperature of 10 degrees Celsius. They're adding them to a polystyrene cup because a polystyrene cup is a good insulator of heat. So it's going to keep the temperature of the mixture. The highest temperature that can be reached is 22 degrees Celsius. So it means once the copper is inside the water, the final temperature that they are going to reach is 22 degrees Celsius. Okay, I collected the information, so I'm going to make sense of it. I have a polystyrene cup. It has water inside of it. And inside the water, I'm going to add a copper ball. I know that this copper ball is at a higher temperature. I know that this copper ball is at a higher temperature than the water because the initial temperature of the water is 10 degrees Celsius. But the initial temperature of the copper ball is 185 degrees Celsius. So it simply means heat is going to come out of the ball to what? To the water. So I know that Q absorbed is going to be for the water. And I know that, can I just erase this part? And I know that the Q lost is going to be for the copper. So I write my formula. Q absorbed is equals to negative Q lost. You get a mark for writing this. Then you go and say MC TF minus TI is equals to negative MC TF minus TI. The absorbed, remember, it's for the water. So I'm going to have 100 divided by 1,000 multiplied by the specific for the water. The final temperature is 22 minus the initial for the water was 10. Negative the mass of the copper 80 divided by 1,000. We are looking for the C. The final temperature 22 minus the initial 185. So this side we're going to have 5020,8, which is going to equals to 13,04 multiplied by C. So how are we going to get C? There are 3 basic mathematical skills that you need to know in order for you to solve any science problem. Transpose, divide both sides, cross multiply. You need to know when to apply these 3 things in order for you to get your answers correctly. So we're going to do what here? Because there's a multiplication, we are going to divide both sides by what? By 13,04. Divide this side also by what? By 13,04. Cancel, cancel. Then what? C is equals to 385,03 joules per kilogram Kelvin. I hope it makes sense. Example 2. A temperature of 45 degrees Celsius is a comfortable temperature for a bath. If there are 50 liters of cold water at 20 degrees in the bathtub, how much water at 20 degrees Celsius must be added to obtain the required temperature of 45 degrees Celsius? So they're saying comfortable temperature is 45 degrees. And we want to reach the 45 degrees because that is the required temperature. This means we are dealing with our final temperature. Okay. If there are 50 liters of water at 20 degrees Celsius in the bathtub, so 50 liters, remember, 1 liter is equals to 1 kilogram. So it means I'm dealing with what? I'm dealing with 50 kilograms of water. Cold water at 20 degrees Celsius. That's the initial temperature. Where? In the bathtub. So it simply means what? If I have a bath, inside this bath, I'm going to have what? I'm going to have 50 kilogram of water at an initial temperature of 20 degrees. Then on it, I am going to add a certain amount, I do not know how much this amount, of hot water and this hot water is going to be at 80 degrees. Once these two come into contact, when the hot water and the cold water come into contact, I know that the final temperature now of the mixture is going to be 45 degrees Celsius. So it means I moved from a 20 to a 45. What happened? The initial temperature was low and the final temperature was high. Did I lose or did I gain? I gained. So it means the cold water gained. Then the 80. We moved from the 80, we went to the 45. What happened? I had a high initial temperature and I went to a low temperature. So it means I lost. You need to be able to identify this. So let's put it into a formula. Our formula says Q absorbed is equals to negative Q lost. MC T final minus T initial is equals to negative MC T final minus T initial. Remember which one is absorbed? The cold one. So it means I have what? I have the mass of 50 in specific 1484. The final temperature must be 45. Initially it was at 20 degrees. Equals to negative. The mass is unknown. I'm still dealing with water, so the specific is still the same. The final temperature is 45. Initial was 80 degrees. So this side I have 5230000, which is equals to 146,440 M. Remember, 45 minus 80 is going to give us a negative value. That negative is going to be cancelled by this negative. This is why our answer is positive. So we're going to divide both sides by 146,440. Divide 146,440. Cancel, and I'm left with what? M is equals to 35,71 kilograms. If you want to express it in liters, it will still be fine. So that means how much will I have in liters? The volume will be 35,71 liters. Last example. A cup of warm water is added to double the amount of cold water at 15 degrees Celsius. The highest temperature reached by the mixture is 30 degrees Celsius. Calculate the temperature of the warm water before the cold water was added. This one is quite tricky because they said nothing about the value of the mass, but it's not tricky at the same time. A cup of warm water is added to double the amount of cold water. So 2 multiplied by M. We don't know how much the cold water is. So double M. That means what? The warm water is just M, the mass. At an initial temperature of what? Of 15 degrees. The highest temperature reached by the mixture is what? It's 30 degrees. Meaning T final. Calculate the temperature of the warm water. Temperature of warm water before the cold water was added. So they want us to calculate the TI. This is going to be interesting. So I have a container. A cup of warm water is added to double the amount of cold water. So the cold water was 2m and they're adding the warm water m. The initial of the cold water is what? Is 15 degrees Celsius. And this one, the initial is our unknown. Together, the mixture is going to have a final temperature of what? Of 30 degrees Celsius. So who lost, who gained? If I move from 15 to 30, what does it mean? I had a lower initial temperature and I went to a higher temperature. It means I am the one that is going to absorb. And then when I look at the warm water, what is happening? I know nothing about its initial temperature. So if this one is going to absorb, it means this one is going to lose, because they can't both absorb or they can both lose. So Q absorbed is equals to negative Q lost. MC TF minus TI is equals to negative MC TF minus TI. The one that's absorbed is the 2m. Multiplied by the C of the water, we know the final temperature, 30 minus 15, is equals to negative m multiplied by 184. Now, I have an advice for you. We know math is not mathing. Can we then leave this as delta T? I'll explain to you why, or I'll show you why. Make life easy for yourself. So this, let's leave it as delta T. Now, what am I going to do? I'm going to divide this side by negative m multiplied by 4184. I'm going to divide this side also by negative m 4184. M cancels m, negative cancels negative, this cancels this cancels that, this cancels that. So I'm going to be left with what? Delta T is equals to negative what? 30 degrees. We agree? Okay. Now I know that delta T is the final temperature minus the initial temperature. So I can substitute that information. So let's write it here. T final minus T initial is equals to negative 30. I know the final temperature is 30. Minus the initial, I do not know, which is equals to negative 30. What am I going to do here? Remember the three mathematical skills? Transpose, cross multiply, divide. Because there's a negative in between, I'm going to transpose. Who am I going to transpose? I'm going to transpose the 30. Then I'm going to have negative Ti is equals to negative 30. Remember, when we transpose, the sign changes. So it was positive this side, so when we transpose it, it's going to be negative. So it's going to be minus 30. So it's negative Ti is equals to negative 60. So we don't want negative Ti, we want Ti. So what are we going to do? I'm going to divide both sides by negative 1, divide by negative 1. Then I'm going to get Ti is equals to what? 60 degrees Celsius. So you see, these problems are easy. You do not need to crack your head to understand these things. Just understand which one absorbs and which one loses. I hope you enjoyed the video. Please leave a comment down below. Like, don't forget to subscribe and share with your friends. Best wishes.